Hi there, Miss Wesley here. We're ready for Unit 7, Skill 9, Part A. So we're coming to the end of this coordinate geometry unit. Yes, it's been kind of a hodgepodge of a lot of different topics, but it kind of ends with something that I think sums up a lot of it and I really like. So our essential question for today is, how do you find the perimeter of regular polygons? So we've been talking about perimeter for many units now, so hopefully you remember perimeter is the distance around a shape, like you were building a fence around something. And just a reminder that the word regular here, when we talk about regular polygons, is those shapes have all congruent sides. So if I was to draw a regular, let's see, like pentagon, as best as I can. 1, 2, 3, 4, 5. Obviously that's not perfect, but I would say that's a regular pentagon compared to, here could be another pentagon. 1, 2, 3, 4, 5. That's also a pentagon, but it obviously has 5 different side lengths. All right, so all the shapes we're going to talk about today fall in that category of regular shapes. So first thing we have to remember how to do is how to break down radicals. So it's important that you know how to do them both in your calculator and without your calculator. So the process is the same for all of them. You first have to remember your list of perfect squares. So 1 squared, 2 squared gives us 4, 3 squared is 9, 16, 25, 36, 49. I always get to know that 7, 8, 64, 81, and 100. That's normally pretty good. All right, so again, that's just 1 squared, 2 squared, 3 squared, 4 squared, so on and so forth. So what you're doing when you're trying to break down radicals is you are trying to figure out what is the largest number from this list here that can divide evenly into your radical. So if I'm thinking about 80 here, and I look at this list and I say, okay, 80 definitely cannot be divided by 64 nicely, 49 is not going to work, 36 isn't going to work, 25 is not going to work, but what about 16? So if I do 80 divided by 16 in my calculator, I get 5. So that means it works evenly. So the next step in breaking down this radical is I break it up, and I put my perfect squares first, so 16, and 16 went in 85 times. Well, the reason I do this is because I know what the square root of 16 is. The square root of 16 is just 4. Just a plain old 4. But I don't know the square root of 5, so I'm going to leave that alone. And that's my answer. 4 radical 5. Alright? So let's try 45, and then I'll have you try the last one on your own. So 45. I look at my list, and I say, okay, 36 is not going to divide nicely into 45. 25 is not going to be nice. I don't know about 16. So if I do 45 divided by 16, nope, I get like 2.81. So let's move on. 45 and 9. That's going to work. Okay? So again, just like I did before, I'm going to break it down. So I break it up. Perfect square goes first. 9 was my perfect square. 9 went into 45. 5 times. The square root of 9. I know the square root of 9 is just 3. Plain old 3. I don't know the square root of 5, so I leave that alone. There's my answer. Okay, so pause the video for me, try the last one, square root of 32, see what you get, and then press play and see if your answer is the same as mine. Okay, so hopefully you started the list, and you always want to go biggest numbers to smallest numbers, because 32 can be divided by 16. 16 goes in twice. The square root of 16 is 4. We don't know the square root of 2, so I leave that alone. Now the reason I said you go biggest to smallest is because sometimes people start at the bottom and they say, don't write this down, this is what people do. They'll say, oh, well, 4 will go in to 32, and they'll break it up and say, well, 4 times 8, square root of 4 is 2 radical 8, but guess what? 8 can be broken up again, because then 4 can go into the 8. So then you keep going in this pattern until it can't break up anymore. So that's why we like to say, start with the biggest square root possible, and then you won't run into that issue. Okay, so we're going to use that information a little bit later on here and in the next unit, breaking down radicals. So let's move on to the actual fun stuff. Perimeter. So like we said, perimeter is simply the distance around a shape. Okay, so shape, not shop. Geez, that looks like a Q. Let's try that again. Shape AP. There we go. So when you were little, you might have counted like with those little blocks to find the distance around a shape. You could measure the distance around a shape. But sticking with our idea that we are in coordinate geometry here, we are going to use some of the skills throughout this unit to kind of put it all together. So let's take a look at this example. It says the vertices of a square ABCD have the following coordinates. What is the perimeter of ABCD? All right. Now, I could graph all 4 of those. I could draw some boxes around them, and I could find the length of each side and then add them up. But I'm using my knowledge of the fact that I know a square has 4 congruent sides. So if I find one of the sides, I know then I just have to multiply that by 4, since there are going to be 4 congruent sides. So if I just plot the first 2 points, for instance, -4, 4, 1, 2, 3, 4, 1, 2, 3, 4, that's going to be here. B is at -2, -4. So B is down here. If I connect them. Okay. So I want to find the distance. So just like we've been doing in a lot of the previous units, I'm going to box this out so I can make a right triangle, because then I know I can do Pythagorean theorem on it. It's also the same as if I was to use the table method. Change an x, change a y. A squared plus b squared equals c squared. Okay, so change in x means how far apart are these horizontally? Well, there's a wonderful distance of 2. How far apart are they vertically? So 1, 2, 3, 4, 5, 6, 7, 8. If I check that up here and I said, well, -4 take away a -2, they're really just 2 apart. That's where this 2 came from. And if I do 4 minus a -4, minus a negative turns into a positive, which gives me 8. So now I'm left to do Pythagorean theorem. 2 squared plus 8 squared equals c squared. 2 times 2 is 4. 8 times 8 is 64. So 4 plus 64 is 68. I know I have to go ahead and square root that. So c equals the square root of 68. But remember, that is the length of just one side. That would be the length of AB. I need to envision this as turning into a whole square. So if I want to find the perimeter of this entire square, I know I'm going to need to multiply this by 4. So my perimeter, my final answer, would simply be 4 radical 68ths. I need 4 of them. So choice 4. Okay. So with these regular polygons, it's really nice because if you can find one side length, you just know to multiply by however many sides your shape has. And we're going to try that in the one last example in the back. Okay, so as you can tell, I apologize, this is a little blurry. This came straight off a Regents exam. It says the endpoints of one side of a regular pentagon. So first I'm going to jot down in my head, as I know pentagons have 5 sides, are -1, 4, and 2, 3. What is the perimeter of the pentagon? So I'm going to take a second to set up my table. Again, you could also do this on the graph. I'll kind of do it both ways, just so whatever way you're more comfortable with, it works for. -1, 4, here, 2, 3, this is a tiny one, so I connect those. So if I go ahead and look for my change in x's, my change in y's, so my change in x's, they're 3 apart horizontally. -1 minus -2 is going to give me a -3. My change in y's, it looks like they're just 1 apart. 4 and 3, 4 minus 3 is just 1. Oh, what did I just do that? 4 minus 3 is 1. So now I go over here, do my Pythagorean theorem with 3 and 1. 3 squared plus 1 squared equals c squared. 3 times 3 gives me 9. 1 times 1 is just 1. 9 plus 1 is 10. 10 equals c squared. I know I got a square root. C equals square root of 10. But remember, that is just one side length of this pentagon. I would have to be finding, oh, this is definitely not a regular pentagon, but I would be needing to find the other 4. So in total, you have 5 sides for a pentagon, remember? So my answer is going to be 5 radical 10s, which is choice 2. Okay? So again, same process before. If you're not understanding any part of it, you also need to make sure you know how many sides your different shapes have: pentagons, hexagons, octagons, decagons, those kind of thing. Try your practice problems, and then go ahead and take your quiz when you are ready. See you in the next unit.